Hey everyone, welcome back to school or distance learning for us from April break. I hope you had a very restful break and that you guys got to catch up on some work or enjoy some of the weather. It seems like it's finally getting a little bit warmer out, so I hope you're able to enjoy your time. So we are going to get right back into the same topic that we looked at before we went on break, which included finding the slope using your slope formula. Before we dive into using the formula, we're going to do a very quick refresher since we had a week off on what slope is. So this was the sheet that I actually uploaded to the Google Classroom that you guys were able to take notes on if you chose to do so. I'm going to encourage in the next couple of weeks, since it's all new topics, if I upload a sheet that says this is for notes, I would encourage you to print it out if you can, and you can write on it taking your notes and going through your examples with us. Or at least copy down the important information. So some things that you're going to notice here are the definitions. So we've already talked about slope being the steepness of the line, right? And so it can be going in 4 different directions. It could be increasing as we move from left to right. That would be a positive slope. It could be decreasing as we move from left to right, negative, going down. If it goes straight across, right, there's no change there, then that represents a 0 slope. And the last one is when we have a straight up and down, a vertical line. And remember, we talked about this. This isn't even a function, and that's why the slope is undefined. We can't physically be in 2 places at once. So when we're finding the slope from a graph, we're just counting the rise over the run. So it's the change in y over the change in x. And so in this case, I had this nice red line. I was able to find 2 good points. Remember what that means. That means I can find the actual coordinate of that point. This point being at 0, 1, and this red point being at 2, 4. So when I say good points, I can actually tell the coordinates of that spot, the exact spot where that point is located. And to get from one point to the other, I count my vertical change, which was 3, and my horizontal change, which was 2, and so the slope of this line was 3 over 2. The same thing is done as if it's going in a negative direction, except when you're counting down 3 units, you represent that by a negative 3. And we're still running or moving over 2 units. So that slope would be negative 3 over 2. So that's a quick refresher on what slope was. We're going to go through 2 examples. One where we find the slope from 2 points using our slope formula. So again, a reminder, you need 2 points when you don't have a graph to count in order to find the slope of that line. And our slope formula finds the difference in y. So the difference between our vertical change, our y values, over the difference between our horizontal change, our x values. So we're going to keep this handy. We're going to keep this to use. And we are going to find the slope between 2 different points. So our first point we're going to be given is the point 3, negative 5. And the second point will be 10, 8. So we just came up with 2 points. I'm giving you these 2 points. So I would like you to find the slope of a line that passes through the point 3, negative 5 and the point 10, 8. So the very first thing we need to do is identify our values. So remember, each coordinate pair that I give you is going to consist of an x value and a y value. So the first number that we come across is representing our x1 value. It's in the x1 position. The second number that we come across in the first point will be our first y value. So this would be the y1 position. So the first x coordinate is 3, the first y coordinate is negative 5. Then we move to our second point. The second point on our line represents our x2, right? So 10 is our x2 value, and 8 is representing our y2 value. So now that we've identified which number represents which coordinate, I'm going to be inputting that into my slope formula. So the way I like to organize this is I always know that it's going to be my rise, my vertical change over my run. So I'm going to start out by drawing a nice long division symbol that I know the top will be the ratio, or I'm making a ratio of my vertical change to my horizontal change. And I know I'm finding the difference between those two values. So I'm going to use a subtraction sign. The first thing I need to look for is my y2 value. And I did this color coordinated so we know exactly which number we're talking about. My y2 value is 8 because that's in the y2 position. So the number that goes right here is 8. My y1 value, the number that's in my y1 position, is -5. Goes right here. That represents the difference in your y values. Now I need to look for my x2 value, which is 10, and my x1 value, which is 3. And so you're going to notice two things. Your y values, your blue and your green, are on the top, and your x values, your orange and your pink, are on the bottom. Something else to note is that your green and pink, which are part of the second point, are lined up with each other, and your blue and your orange, which are part of your first point, are lined up with each other. And then it's a matter of simplifying. So we're going to do the math. 8 minus -5, which is actually the same thing as 8 plus 5, right? And if you're not sure, you're going to keep 8, and it's the same thing as adding the opposite of -5, which would be +5. And 8 plus 5 will give us 13. And I do the same thing at the bottom. 10 minus 3 is going to be 7. So the fraction 13/7 cannot be simplified, and we are going to leave that as an improper fraction. And just a quick reminder, the letter that represents slope in our case is m, and so I can actually say that m is going to be equal to 13/7. So the slope of the line passing through these 2 points is 13/7. That's how we find the slope. So another thing that we can look at is if we aren't given 2 exact points, but we're looking at a table, we can actually use the exact same formula, because a table is just a set or lots of ordered pairs. So I can actually write this first x value at 0 and y value at 20 as the point 0, 20. So all this table is doing is organizing your ordered pairs in a different way. We talked about this when we looked at our functions unit. The second point would be 2, 16. There's a third point at 4, 12, and a fourth point at 6, 8. Now something important to note, whenever we're finding the slope using our slope formula, we actually only need to have 2 points. Now we have 4. It is totally fine whichever 2 you choose. I like to look at the first 2 points because then I know I can look at maybe not having to simplify. It's not always the case, but sometimes we get lucky. In this case, it's not. But I like to look at the first 2 points because that will usually give me the smallest numbers to work with. So the first point I'm going to use, and I'm going to set them up in this way, is going to be the point 0, 20. 0, 20 will be my first coordinate pair. And the second coordinate pair that I'm going to use is 2, 16. So all I've done so far was chosen 2 of these points that I got right out of this table. And now I'm going to do the same thing where I organized which value represents what coordinate. And so if I'm looking here at 0, and this is my first point, then 0 would be my x1 value. And if I'm looking at 20, that's the y value in my first point, so that will be my y1 value. The 2 represents my x2 value, and 16 is going to represent my y2 value. So again, I have all 4 numbers labeled, my x1, my y1, my x2, my y2, and then it's a matter of substituting these values in for our slope formula. So again, m is the letter that we use to represent slope, right, how our line is moving. We know we're looking at the ratio of our vertical change to our horizontal, and we know we're looking at the difference in those values. So I'm going to organize my slope formula. by substituting in the appropriate value. So again, y2 was 16. Then I have my minus sign, and I'm looking for my y1, which is 20. Then I have my x2 value, which is 2, and my x1 value, which is 0. And so now I don't have any negative numbers to worry about. I have subtraction to deal with. So I'm going to take care of the top first. 16 minus 20. It's actually, you have a greater debt than you have positive numbers. So 16 minus 20 is negative 4. And 2 minus 0 is 2. And again, this is being represented by m, right? Because our slope is m. But when I look at this fraction, I can see that it can be simplified. And so negative 4 over 2, our numerator and our denominator have a common factor of 2. So I can divide both the top of my fraction and the bottom of my fraction by 2 to keep it equivalent. So negative 4 divided by 2 is negative 2, and 2 divided by 2 is 1. So I now know that the slope of the line that uses these coordinates in this table is negative 2 over 1. You can also write that just as m is equal to negative 2. I'm totally fine with you leaving it as a ratio, even though negative 2 can be written as an integer. We're going to leave it as negative 2 over 1 or as negative 2. So that's how you're going to use your slope formula, and today's quizzes is going to be very similar to what it was last week before we started break, but this time you're going to see some tables in there. So whenever you have lots of points to work with, remember you only need 2. You're going to pick out which 2 points you'd like, label them appropriately, and then substitute them into our slope formula. And then it's a matter of doing some arithmetic. Start by simplifying the numerator, simplifying the denominator, and then if you need to, simplifying your fraction. Remember, we always write our fractions in simplest form. So again, if you need to pause the video at any time to write down your formula, or if you need to use colored pencils to help organize, I strongly encourage you to do that. If you have a highlighter at home, that might help you out. Okay, so we are going to continue looking at slope and moving through this, and even some graphs next time. So if you are having any trouble, I'm going to post a couple of other videos that I found on the internet, and then let me know by emailing me if you have any specific questions. Okay? I miss you guys.